in the cosmos as a whole.
It's important to realize that astronomically, the seeds of life on Earth were sown 4.5 billion years ago when the Sun and solar system formed. That's a long time back in the past. But we can ask ourselves now, can we see the seeds of life in other galaxies in great abundance back then, or maybe even perhaps earlier than that?
Sandy uses the Keck telescope as a kind of time machine that can look deep into the past. Its giant mirror, 36 feet across, can capture a snapshot of galaxies when they were much younger than our own. But merely seeing such distant galaxies is not enough. Sandy wants to discover what they're made of. To find out, she uses an instrument called a spectrograph. Sandy's spectrograph, called DEIMOS, is one of the most powerful in the world. It takes the light from up to 150 galaxies at a time, each isolated in a single hole in a sheet of metal called a slit mask. DEIMOS then breaks that light up into the visible spectrum, the rainbow of colors from violet to red. Zooming in on a galactic spectrum reveals a forest of bright and dark lines, patterns that reveal the presence of particular elements.
Using spectra as our tool, we can tell you what elements exist in that galaxy: oxygen, carbon, iron. And we can tell you whether the galaxy is rich in those elements, has the broth cooked a lot, or is it still too dilute to make planets.
That's what Sandy will do tonight. Measure the amounts of heavy elements to determine each galaxy's readiness for life. Sandy and her team ultimately plan to examine 65,000 galaxies in all, in a massive census dubbed the Deep Survey.
There we go.
Oh, beautiful. Oh, isn't that great?
Here are the results, hot off the telescope.
This is fantastic.
That's the kind you're talking about.
That's oxygen, and oxygen here.
This bright spot marks the presence of oxygen in a galaxy 5 billion light years away.
Just purely by coincidence, we're looking at galaxies, their light left just when our sun was forming in our own galaxy, right? And so this one here...
Sandy uses the sun's level of oxygen and other heavy elements as her benchmark. If a galaxy has a similar mix of elements, then potentially it could support the same living chemistry we find here at home.
So that galaxy would be a really good place to look for planets, because it's even more abundant in metals than our own galaxy is.
Two years into a projected 10-year observing program, the Deep Survey team has already detected thousands of distant galaxies that are rich in the elements of life. And that leads to a startling conclusion.
Our universe is hospitable to life. There are billions and billions of galaxies everywhere, cooking elements, making stars that are right for solar systems. The habitat for life is everywhere.
That's no proof that life itself exists anywhere else in the universe. But Sandy's work does confirm that the elements essential to life as we know it are widespread throughout the cosmos.
The message of the Deep Survey and all the other information that we're getting is one beautiful story, a new version of Genesis, a new version of the cosmic myth, only this time it's scientifically based. From the Big Bang to now. Big Bang, formation of galaxies, formation of heavy elements and supernova, sun, earth, life. One unbroken great chain of being.
Just in the last few years, we've reached the point that we can start with the origins of the universe. We can end with a conversation among intelligent beings about how things work, and have an awfully good understanding of every step that came in between the two.
It was as if we're basically assembling this puzzle. And all of a sudden, you look down at the puzzle and you realize you've got it. The pieces are there.
For almost all of human history, the heavens have been beyond our reach. For our ancestors, it was a place where the gods lived, or else simply a vast, untouchable realm of lifeless beauty.